So today our job is to continue where we were at yesterday. We're going to keep talking about concavity, and we're going to kind of build those two things together. A reminder that Wednesday in class we are going to review. Thursday you will not be here because of the PSAT. And then Friday we are going to take a quiz over this. So make sure that you're locked in enough to be ready for that. Okay, here it says f prime of x is greater than 0. And f double prime of x is less than 0. Which of the following could be a value for f? So these are different tables of f, and they told me about f prime and f double prime. Show me with your fingers. What'd you get? 1 for A, 2 for B, 3 for C, 4 for D. 1s, 2s, and 4s seem to be the theme. 1, 2s, and 4s. All right, let's figure it out. If f prime of x is greater than 0, what does it mean if f prime of x is greater than 0? Slope is positive. So what does that tell me about f? F is increasing. Don't say the slope is increasing. F is increasing. Okay, because f prime is positive, means your line is going up, which means each time your y value is getting higher and higher. So based off of that alone, which one of these answers can I eliminate? A. It goes 4, 3, 1. The y value is getting smaller. It is not A. Okay, f needs to be increasing. The second thing is f double prime is less than 0. Show me with your hand. What does it look like if f double prime is less than 0? F double prime is less than 0 means you are concave down like a frown. Okay? So my job is to figure out which one of these 3 graphs is concave down like a frown. We could do it by looking at the numbers. Let's look at the graphs and then figure it out from there. So when in doubt, graph it out is always our theme. Boom, negative 1 and 1. 1, 2, 3, 4, 5, 6, 7. This one goes 4, 6. Just kidding. That's not 6. That's 5. 4, 6, 7. A graph like that. 1, 2, 3, 4, 5, 6, 7. This one goes negative 1, 4, 5. Yeah, I can't put a dot in the right spot. 4, 5, 6. It goes like that. 1, 2, 3, 4, 5, 6, 7. 4, 5, 7. Which one is it? A, B, C, or D? B. I need to be concave down. The only one that fits that description is B. It's concave down like a frown. What could you have done without graphing that? How else could we have made that distinction? Talk with your neighbor for a second. How, without graphing it, could we have known that that was going to be true? All right, somebody got an answer for me. How can I tell based off of that, based off of the chart? Luke, what did you say there? How could you tell based off just the charts? Good. So he is describing the slope. And if f is increasing, he's saying the slope. So f prime, if I'm concave down, that means f double prime is less than 0. What does that tell me about f prime? If I'm concave down, f prime is going to be what? It is decreasing. That is something we talked about yesterday. Concave down, f prime decreasing, and f double prime less than 0 is all the same thing. The slope needs to be getting less and less. So Luke said here the slope is 2 and then 1. That is getting less. That means it's concave down. Here the slope is 1 and 1. It's the same. It's constant, just like we see. Here the slope is 1 and then 2. The slope is getting steeper. If the slope is getting steeper, I'm concave up like a cup. That's not the one I wanted. I wanted B. Make sense there? This phrase right here, f prime is decreasing, is the same thing as concave down. All right, let's pull out our notes from yesterday, and let's continue. All right, so example 3 yesterday. I did it in a couple of my classes. You guys were running a little bit behind, so we didn't get to it. This is an important problem. I'm going to put a single star by it So you remember that maybe you should look back at it before Friday's quiz, because it might be fairly important in order for you to do well on it. So I'm just going to put a star here, just real quick, to make sure that you know that it's an important problem. Just a single star. That's it, just one. Okay? It's important. Make sure we know what's going on. Find the x values for the points of inflection. Find the x values for the points of inflection given this f of x. So I've got f of x. It is my job to find a point of inflection. What do I need to do to find a point of inflection given f of x? I need to take a derivative. Let's take a derivative. Find f prime of x. What's the derivative of e? Derivative e is what you see times derivative of the exponent, derivative of negative x squared, so it's negative 2x. Great, I found the first derivative. Now what? You got to find the second derivative, because points of inflection are a second derivative question. So I got to find f double prime now. Take a second with your neighbor and find the derivative. Not forgetting about some important things like product rule. Taking the second derivative, so we need product rule here. Michael, what'd you do here for product rule? So first, e to the negative x squared times negative 2, the derivative of the second. So first derivative of the second plus the second, negative 2x, times the derivative of the first, which the derivative of e is what you see, times the derivative of the exponent, which is a negative 2x. Everybody good with finding that second derivative with product rule? It's all being multiplied, so it doesn't necessarily have to be in parentheses. Good question. If there were plus or minus signs, then yeah, but it's all being multiplied, so I'm good. All right, so that's really ugly. I'm just going to clean it up a little bit. Let's just rewrite f double prime. Negative 2 e to the negative x squared. I've got a negative 2x and another negative 2x that I'm multiplying together, so positive 4x squared e to the negative x squared. Super yucky, but oh well, we got to do it. What do I need to do with that now? Ooh, yeah. Set it equal to 0. I need to figure out when that is 0. Thoughts on what I can do for that? How can I figure out when that thing is equal to 0? Andrew? Yeah, they both have an e in them. They both have this e to the negative x squared. You can take out a 2 and a negative 2 and all that. Let's not, because it actually makes it easier to not take it out. But you are correct. That is a great way of doing it. It'll just be easier for all of us if I don't. Okay, and if you did it, you wouldn't be wrong. E to the negative x squared. They both have an e to the negative x squared in it, so I factored it out. Then I'm left with negative 2 plus 4x squared. Cool. I'm taking each thing and setting it equal to 0. So e to the negative x squared is equal to 0, and negative 2 plus 4x squared is equal to 0. This is the reason why I put 27 stars on this thing. It's this guy right here. When is e to the negative x squared going to be equal to 0? Show me with your arm. What does an exponential function look like? That's an exponential. What does an exponential function look like? This is an exponential. Okay? A reminder, it looks like this. That's an exponential function. When is that graph right there? And I did it a little bit poorly. When is that graph going to get you 0? It doesn't. When is it going to get you negative? It doesn't. So that is not going to get me a point of inflection because it's not 0 and it's not going to be negative. It just doesn't happen. Exponential functions don't get you 0. Everybody with me on that? Then we solve the other one. So the other one we just straight solve. 4x squared equals 2. Divide by 4, divide by 4. X squared is a half. So x is going to be equal to plus or minus, good, that's what I wanted to hear, plus or minus the square root of a half. Okay, sorry, I'm getting kind of ugly over there. I don't have a lot of space. But I'm doing an f double prime number line because I'm trying to find points of inflection. I want to look at the second derivative. I'm putting two numbers on there. Negative square root of a half and a positive square root of a half. And I'm plugging in to that equation. This is the equation I'm plugging into on my number line. What's the number I want to plug in? I always plug into the second derivative because this is a second derivative number line, right? So I'm going to plug it into the second derivative. And you could plug it into this one, but I always like plugging into the factored version because it's easier 95% of the time. What number should I plug in? 0. If I plug in 0, I'm looking for numbers in here. The good news here is what is going to be true about this every single time? It's always positive, no matter what I plug in, because it's an exponential function. Exponential functions look like that. Okay? All right, so that's always positive. So if I plugged in 0 here, positive or negative? Negative. Boom, it's negative. I need to plug in something else, something bigger than square root of 1/2, so 10 billion. It's positive. It's positive. Plug in a number less than negative square root of 1/2, so negative 10 billion. When I square it, it goes positive. It's positive. There is my sign chart. That is going to allow me to answer this question. Where are the points of inflection? You have a point of inflection at x is equal to. Explain to your neighbor. How do you know that plus and minus, the square root of 1/2, are points of inflection? Talk to each other. Those two values are points of inflection. Okay? Macy, how do we know that those two values are points of inflection? The sign changes of what? What was that sign chart of? There you go. Points of inflection are when f double prime changes signs. So the sign changes on f double prime. That's the key to this. Wonderful. Questions there? All right, that was the tough one for the day. Nothing else is anywhere close to that difficult. Okay, let's go to the next one. Okay, if f prime is 0 and f double prime is less than 0, that's what's here's what we're talking about. Okay, this is called the second derivative test for local extrema. What we're doing in these problems is we are determining from a limited amount of information whether something is a maximum or a minimum. Okay, you only need this in AP calculus because they're not giving you enough information. They're giving me some information but not everything, and so I can use the second derivative test to help me out. So here's what it says. F prime of c is equal to 0. If f prime is 0, show me with your hand, what does f prime is 0 mean? F prime is 0 means what? It's like this. You got some point, and the slope is 0. That's what f prime of c equals 0 means. Here it says f double prime at that value. So they're just talking about some c. Like it doesn't matter. Imagine you had a graph. We just picked some value c. The slope is 0. At that same c value, f double prime is less than 0. Show me with your hand, what does f double prime is less than 0 look like? You are concave down like a frown. So this means I'm concave down like a frown. Okay, so that means at this spot, I'm also doing this. My slope is 0 and I'm concave down. So if your slope is 0 and you're concave down, what does that tell you about C? What does that tell you about that point right there? It's a maximum. It's got to be a max. The slope is 0 and you're concave down. There's concave down. That's where the slope is 0. It's a maximum. It's the highest point on my graph. Make sense? So the other thing would also be true. If my slope is 0, so pick a point, make the slope 0, and then f double prime is greater than 0. If f double prime is greater than 0, what does that mean? I'm concave up like a cup. If I'm concave up and my slope is 0, what does that mean about that point right there? It's a minimum. That's not that deep. Okay, just think about it. If your slope is 0 and you know about the concavity, it will tell you whether it's a maximum or a minimum. Questions so far? Now let's do it. Example 4. Okay, if they didn't tell me to use the second derivative test, I wouldn't use it. It's a good test, but it only works when I'm given limited information. And here, that's not necessarily what they're doing. Use the second derivative test to determine if x is equal to plus or minus 2, our maximums or minimums, and then we're going to justify our answer. All right, so normally, they gave me f of x. They're asking me, is it a maximum or a minimum? Normally, I would find the first derivative. I would set it equal to 0. I would solve. I'd put it on a number line, and it would tell me what's going on. Okay, let's do that. So f prime, I'm going to take the derivative. So 3x squared minus 12. Normally, I would take that thing. I would set it equal to 0. And I would solve. Oh, yeah, x is plus or minus 2. We already knew that. They already told me that x was going to be plus or minus 2. Those are the things we're deciding if max or min. If we wanted to, we could make a sign chart and put -2 and +2 and find the max and mins from there. But that's not what they're asking. We could do that, but that's not what they're asking. Here they're saying use the second derivative test. So if I want to use the second derivative test, what do you think I need to do now? Find the second derivative. So let's find f double prime. F double prime here would be 6x. Solve that thing. Make an f double prime sign chart. Go. Here we go. We are making a sign chart. So we took the second derivative. We're going to set it equal to 0. What number am I placing on this sign chart? Just 0. 0 is my only number. I'm going to pick some numbers and plug them in. Aaron, what number do you want to plug in? 1. He's plugging 1 into 6x. Is it going to be positive or negative? Positive. So over there it's positive. He plugs in a number less than 0, like -1. It's going to get you negative. From that alone, we can make the distinction on this right here. We can now answer the question, x equals 2 is a blank. Is it a maximum or is it a minimum? And then we can give a justification. Our justification is going to say, oh, because the first derivative was 0. That's what we found right here. When we found the first derivative, we got 0 at plus or minus 2. And then something else. Talk with your neighbor. Finish those two sentences. X equals 2 is a blank because f prime of 2 is 0, and what else? Okay, same thing with the second one. Talk to each other. Think about why it is what it is. Get a good explanation. Here you go. Show me with your hand. X equals 2 is a what? Show me with your hand. X equals 2 is going to be a what here? X equals 2 is going to be a if it's positive. F double prime is positive. What does F double prime is positive mean? What is true about the graph if F double prime? F double prime at 2 is positive. So what does that mean is true about your graph if F double prime is positive? It's concave up. If it's concave up and the derivative is 0, what does it make that point? That is a minimum. Same thing on the second one. X is equal to -2. It's going to be a maximum because the slope is 0 and f double prime at -2 is negative. Because if it's negative, that means I'm concave down like a frown. And if I'm concave down and my slope is 0, the only answer is that is a maximum. Okay, here is a visual picture of what we just did. Here's the problem that we started with. Okay, here is 2 and -2. Oh yeah, that one is definitely concave down. And when it's concave down, it's a max. This one is definitely concave up. And when it's concave up, it's a minimum. And the other place we found was 0. 0 is that point of inflection. It's when the second derivative changed signs. I'm concave down, 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 down. And then I got to flip at 0, and now I'm concave up. Everything we wanted to know, we can look at that picture and figure out. Questions there? All right, let's go to the backside. Example 5. This is when we need the second derivative test. That last question, it would have been way easier just to use a sign chart on f prime and figure out maxes and mins. But this is when we need it, when they're just giving me some information. Okay? Let f be a twice differentiable function. F at -7 is 6. F prime at -7 is 0. And f double prime at -7 is -5. What occurs in the graph of x at that point, -7, 6? Talk with your neighbor. Think about it. When in doubt, graph it out. Figure out what's going on. Go. Show me with your hand what is happening at the graph at the point -7, 6. Show me with your hand what is happening. All right, so we've got some maxes, some mins. When in doubt, graph it out. So I'm going to do that real quick. Okay. If I did that, -7, 1, 2, 3, 4, 5, 6, 7. Who cares? It doesn't have to be perfect. 1, 2, 3, 4, 5, 6. There is a point. That's what that tells me. If f prime at -7 is 0, what is that telling me? The slope is 0. That means it's a critical number. That means it can be a max or min. If your derivative is not 0, it doesn't mean it's a max or min. And then the last one, f double prime is -5. If f double prime is negative, what does that mean? Down like a frown. So if I'm down like a frown, that means it is a maximum. Maximum on that. Questions there? All right. Let's look at the next one. Example 6, without graphs, this is really ugly. So I went ahead and graphed it. I'm not even asking you to do anything besides look at the screen. Okay? Here's f double prime. That's this guy right here. F double prime is there. G double prime is here. And H double prime is here. The first thing you would do is graph that on your calculator. I already did it for you. I sped up the process. So I really don't even care about those equations. All of these graphs, the twice differentiable functions f, g, and h have second derivatives that are graphed. Which of the functions have exactly 2 points of inflection? Think about what these graphs are, and think about what you need for a point of inflection. Come up with an answer with your neighbor, A, B, C, or D. All right, show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. What you got? 1s and 3s seem to be the two themes. The key to this question is, what does point of inflection mean? Okay, and in particular, they gave me graphs of double prime. So a point of inflection means f double prime, the second derivative, has to do what? F double prime changes signs. All right, this is a graph of the second derivative. So I want to know when this second derivative changes signs twice. Okay, so let's look at, everyone said G worked. Everybody said G worked. Right here, what is true about the second derivative? Positive or negative? Positive, because it's above the x-axis. Then the second derivative is negative. And then the second derivative is positive. How many times did it change? 1, 2. 2 times it changed. Those were both points of inflection. Everybody go with me on that one? On H. Question? Okay. On H, no one said H worked. It goes from positive to negative. That's 1. Right there, it goes from negative to positive. That's 2. Right there, it goes from positive to negative. That's 3. Right there, it goes from negative. Oh, that's way too many. That's 4 POIs. This one had 2. So it's not H. So we don't want D. We don't want B. The only other one is C. What do we think? Letter C. Thumbs up if you think it has 2 points of inflection. Thumbs down if you think it doesn't. It's got 2. Right here, it goes from positive to negative. That is a point of inflection. Right here, it goes from positive to negative. That's a point of inflection. Right here, is that a point of inflection? Because what happens? It goes from positive to positive. It has to change signs. Not just be 0, but it has to change signs to be a point of inflection. Does that make sense what we did there? It's a good question. Making sure you understand the second derivative. One more. This is one they ask quite a bit. On the free response, or I'm sorry, on the multiple choice section, pretty good chance that this is going to pop up, and it's not a tough one. Let f be the function defined by this thing right here. If I were to do it, I would put it and reorder it because I don't like that it's backwards order. But what is the largest open interval on the graph where f is both concave up and increasing? Concave up and increasing. What derivative are we talking about if we're talking about concave up? Second derivative. So this is a second derivative question. If I'm talking about increasing, what derivative am I talking about? The first. Okay, I need both things here. So let's start off. We're going to find f prime. I hate that it's in this order, so I'm going to rewrite it as negative 2x cubed plus 6x squared minus 3. Find the first derivative. If I want to figure out when it's increasing and decreasing, what am I going to do with that first derivative? Set it equal to 0 and solve. Do that. Figure out where the zeros are. Find an f prime. Put it on a number line. See what you get. Go. So I set the derivative equal to 0. Cannon, what'd you do from here?
Oh, I took out a -6.
Okay, so if you took out negative 6x, you're left with x and then x minus 2. Cool. He set each thing equal to 0, so he gets x is 0, x is 2. So on his number line, he's putting 0 and 2. He's then going to plug in numbers. Okay, Talon, what number do you want to plug in here? 1. What do you plug in 1 into? The derivative. And again, I'd plug it into this one right here. When you plugged in 1, here if you plugged in 1, you get negative. Here if you plug in 1, you get negative. It's positive. Okay? And when we pick a number bigger than 2, like 10 billion, if I plug in 10 billion, that's going to be negative. 10 billion, that's going to be positive. That's negative. Negative 10 billion. This would be positive. That would be, okay. Cool. There's my setup. The question asked, where is it increasing and concave up? So which answer can I eliminate right now? A, B, C, or D? Which one do I know is not the answer? D. D doesn't make any sense because it's not increasing over here. The only answer that we could get is something between 0 and 2 because we said that's where f prime is positive. That's when I'm increasing. Everybody good to that point? Now we got to do concave up, so I'm going to go a little bit quicker here. Let's do f double prime. Alana, what's my second derivative going to be here? Negative 12x. Good. Plus 12. There's my derivative. Take that thing, set it equal to 0. Everything else is the same. Subtract 12. Divide by negative 12. X is 1. Just like the first one, I'm going to do a second number line. This time it's f double prime. One thing I like to do on these problems is I like to match up my number lines. It just helps me out. So wherever I had that number line, I'm going to put 1 on this number line where it would fall on the first one. Just it makes everything a little bit easier to read. Okay, so 1 goes right there. I need to plug in some numbers. Plug in 0, and I'm plugging it into negative 12x plus 12. If I plug in 0 there, I get positive. If I plug in a number bigger than 1, I get negative. So look at those answers. The question is, when am I concave up and increasing? Think about it for a second. A, B, C, or D, which one of those make the most sense? Show me with your fingers. 1 for A, 2 for B, 3 for C, 4 for D. Which one do I want? Concave up. What needs to be true about f double prime? If I'm concave up, what needs to be true about it? Positive. And so I'm concave up from 1 to the left. I'm increasing between 0 and 2. So I always like to put these on top of each other because which answer do I want? This one right here. That's where they overlap. 0 to 1 is when it is both concave up and increasing. That's the biggest interval because it's the only interval where that happens. Makes sense what we did there? Little strange, but it's exactly what's going to be on your quiz. Okay? Being able to find when I'm increasing, decreasing, points of inflection, concavity, all of those things